Hi everyone, it's Mr. Oaks, and I'm going to go through a couple of examples changing decimals to fractions. I'm going to start off with an easy one and then increase the difficulty as we go along. I'm also going to walk the wrong way. So the first one I have here is a basic changing decimal to fraction. We have a terminating decimal, 0.78. It's very important for us to remember decimal placement and remember how many decimal places they each were. So we have here a two decimal places. That brings us to the hundredths, and that's important because the number that we say, the hundred, so the first decimal place is the tenths. Well, if something stopped there, we would put it over 10. This is the hundredths, so what I'm going to do is I'm going to put 78 over 100. Okay, I'm actually going to use a different one to see if I can make it a little darker. 78 over 100. Okay, we're always going to want these in simplest form, and if we look, 78 over 100, 78 and 100 have something in common. They're both even, so they both can be divided by 2. $78 divided by 2 gives us 39, and 100 divided by 2 gives us 50. Now I'm always going to go back and double check to see that I did actually use the largest number that goes into both by looking and saying, do 39 and 50 have anything in common? The answer is no. So this is our answer. And that's easy. That the converting from a terminating decimal to a fraction should be easy because you're just using the last place value that the decimal goes to as the denominator. So if it goes to the tenths, you use a 10. If it goes to the hundredths, you use 100. If it goes to the thousands, you use 1,000, and so on and so on. All right. Remember, decimal places are to the power of 10. But then we get to repeating numbers, and repeating numbers take a little bit more effort. So I have here 0.333, and then you see I got dot dot dot, which means it's repeating. Well, with the repeating decimal, I can't just put it over whatever the decimal place it ends at is because it's repeating. It doesn't end. So what I'm going to do is I'm going to make an algebraic expression. So the first thing I'm going to do is I'm going to go, okay, well, my x is going to equal my 0.33 repeating. Okay? So my x is always going to be the number I start off with, the repeating decimal I always start off with, 0.33. And then what I'm going to do is I'm going to look and say, well, how many decimal places does it go before the number starts repeating? You know, how many decimals, what's the first decimal place before it just starts repeating and repeating and repeating? So when I look, I have here's 3 in the tenths. Well, the next number is also a 3, and then another 3. So this number here is the one that's repeating, the one that's in the tenths place. So now instead of using that as my denominator, what I'm going to do is I'm going to multiply x, and really this number, by 10. So I'm going to do 10x equals, and 0.3333 repeating, when I multiply that by 10, that's going to move the decimal place one place to the right, and now what I'll have is 3.333 repeating. Okay? And then I'm going to subtract these. I'm going to subtract one from the other. When I do 10x minus 1x, because that's what x is, it's 1x, all right? I've got 10 minus 1, that gives me 9. So I have 9 x's. And now something nice is going to happen. When I subtract 3.3333 repeating and 0.3 repeating, well, the repeating part's going to disappear. And all we're left with is 3. Now I have a one-step equation, and I'm going to just do what I need to. This is multiplication, so I'm going to divide. I'm going to divide by 9. Divide by 9 on both sides. X equals, and if I look, 3 and 9 have 3 in common, so I'm going to divide by 3 on top, divide by 3 on bottom, and I get 1 over 3. So far, not too bad. Now when everything's repeating, it makes things really easy because I just have to look and see, well, what's repeating? What is repeating? How many decimal places does that take up? So in this case, we have 0.57 repeating. You'll notice this time I used the repeating line over it. I'm going to do the same thing. Okay, well, I'm going to start off, and X is going to be my 0.57 repeating. And how many places did we go? 1, 2, so this is the tenths, this is the hundredths. So we're going to multiply this by 100. So I got to multiply this by 100. So I have 100x equals, well, multiply this by 100, it's going to move the decimal place twice, so we're going to have 57.57 repeating. Okay? Again, I'm going to subtract. 100 minus 1 is 99, so that's 99x. And then again, when I do this subtraction, the repeating part is going to disappear. So we're just going to be left with 57. So I'm going to then do like I did before. I'm going to divide by what's multiplying the x. So I'm going to divide by 99 on both sides. That's going to cross out. I'm going to get x equals, and then I have to go, well, what goes into both 57 and 99? Well, they're not even. A little trick is to go, and I'm going to add these two together. 5 plus 7 is 12. That can be divided by 3. 9 plus 9 is 18. That can be divided by 3. So I'm going to divide both the top and the bottom by 3. When I do that, I get, I gotta double check my thing, 19 over 33. 19 and 33 have nothing in common. So, there's our answer. Okay? So now we're going to go one more decimal place. So you'll see kind of how this just works no matter how many decimal places you have repeating. 0.746 repeating. So that means that this 0.746, 0.746, actually I should have done, that's repeating. That's a little better. But I'm going to do this again. Alright, I'm going to have x equals 0.746 repeating, tenths, hundredths, thousandths. So I'm going to multiply this by 1,000. So I'm going to have 1,000 x equals, well, 1, 2, 3. When I move it to 3 places, I have 746. 746.746 repeating. Again, do my subtraction. 1,000x minus 1x. That's going to give me 999 x. And then 746. And the repeating decimal part goes away. That's really what we're trying to do with these, is kind of get either rid of the decimal or just make it a terminating decimal, and that's going to become important in the next problem. So I'm just going to take the same steps I do. I'm going to divide both sides by 99. Now, I know that cancels out. Once we get to the big numbers, now kind of playing around, go, oh, you know, what numbers can I do? This is even, this isn't. So, can't be 2. Which means no even numbers will work. When I add this up, 7 plus 4 plus 6 comes out to 17. Can't be divided by 3. So any multiple of 3 is not going to work. Neither one of these ends in a 5 or a 0, so no multiple of 5 is going to work. And if we go through a couple more things, we'll find that really, that's it. There's our answer. 746 over 99. That is our answer. That's the fraction in simplest form. Okay? We got one more. Because not everything is going to have every number in the decimal repeat. What I have here is 0.96 repeating. And I'm saying it like that because you'll notice that the repeating line is not over the 9. That's important. That means that when I look at this, really what I have here is 0.9666666666, and it's the 6 that's repeating and going on. Now, our steps here are not going to change. When I change a repeating decimal to a fraction, I'm going to continue to do that, figuring out, well, where does the repeating start? Where does the repeating start slash what is repeating? And that's where the decimal, our number of decimal places go. So first thing again I'm going to do, x equals 0.96 repeating. This doesn't repeat. This is the only thing that does. That's 2 decimal places, so that's the 100th place. So we're going to multiply this by 100. Now you might be like, Mr. Oakes, we already did one like this, so how is this different? Here's where it becomes different. When I look at this, 100 times 9.96 becomes 96 point, and then I'm going to have the 6's repeat. So this is all going to repeat, this is all going to repeat. So these 6's are going to cancel out nicely. Here, when I do my subtraction, well, I'm still going to get 99x over here, but over here, I'm not getting a single number, I'm getting something that still has a decimal. So when I do this, well, I'm going to have to borrow from here. And I get 95.7. So when I divide by 99, my x, my fraction has a decimal. I don't like that. I don't want that. I don't want it. I don't want it. I don't want it. I need to get rid of that decimal. So what I'm going to do is I'm going to multiply the top and the bottom by the same number. There's 1 decimal place, so just as we did before, that's tenths. So I'm going to multiply both of these by 10, which is going to give us 957 over 990. Now I got to figure this one out. So what's good is if you have a scientific calculator, there's usually a fraction to decimal key, and usually there's also one way to write fractions into the calculator, and then the calculator will simplify it for you nicely. But you should kind of have an idea, because a lot of times you're going to have to show your work. That's where this comes in. But I get to this point, and now I look at it and I go, well, what goes into both of these? You know, how do I know I'm right? Luckily, then there's two numbers we could do that will work. The first number I might start off and I might realize that, hey, 3 goes into both of these numbers, but it's not going to get us all the way, because then we will have to divide by 11, because our answers will give us, oh, this is something that's divisible by 11. What actually is going to work with the best number for this is 33, because 3 times 11 is 33. So when I divide both the top and the bottom by 33, I get 29 over 30. And that is how we convert repeating decimals into fractions.